Hi everyone, my name is Dineshwaran and I'm going to present about the block diagram, the MATLAB circuit, and finally the calculation for the transfer function. Let's start with the block diagram. This block diagram we use to represent the control system, and it can be used to calculate the overall transfer function. So this is a normal control system block diagram, and we are doing the greenhouse temperature control system, so we added PID controller to it. So let's start. The signal in the block diagram. Block represents the input, which is the RS input, and the signal out of the block represents the output, which is the CS output. And the block itself, which is the GS, is the transfer function of the system. And we added a summing point and a PID. Get a feedback signal, which is HS. So the summing point in the block diagram represents the dynamic summation of two signals. So, and this is the takeoff point, which in the block diagram represent a point where the signal branches out. So this is the takeoff point. So next is the MATLAB circuit. This is our MATLAB circuit. And next is the transfer function calculation. So to find the transfer function of a closed loop system, we use a feedback system equation. For a system with unity feedback, the closed loop transfer function Ts is given. So the Ts, or we can call it the Cs over Rs equation is this. And the Gs is the open loop transfer function. And the Hs is a feedback transfer function, which is usually one for a unity feedback. In this case, the open loop transfer function is Gs equals to 2 over S power 2 plus 2S plus 3. And for Hs, it is 1. So after we substitute these values into the Ts equation, we can get the final value to be 2 over S power of 2 plus 2S plus 5. And this is the equation to find the damping ratio. And finally, we get answer for the damping ratio. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad AZAMUDDIN bin Ismail. Okay, hari ini kita akan mencarikan peak time, cycling time, percent overshoot dan juga steady state error. Okay, peak time first TP ataupun TP kita akan masukkan formula pi sama dengan omega n sama dengan 1 tolak zeta 2. Okay, masukkan formula, lepas tu kita masukkan nilai apa benda yang kita dah cari. Lepas tu kita akan cari cycling time untuk settling time pula TS, kita lepas tu masukkan nilai benda yang kita dah cari, kita akan dapat 4 second. Lepas tu percent overshoot OS, masukkan formula, lepas tu kita dapat dalam 25.2% saja. Lepas tu steady state error ni, ESS ni pula masukkan formula, kita dapat dalam 0.6. Okay, this result indicate dalam temperature control yang kita moderate response, speed dalam peak dalam 1.4 second. Lepas tu lepas tu benda ni settle dalam 4 second. Lepas tu kita ada percent overshoot dalam 25.2%. Lepas tu sistem ni ada steady state error untuk state input dalam 0.6. Benda ni indicate dalam accuracy accurately reach dan maintain dalam desired punya temperature.
Okay, hi, my name is Ravin. So today I'll explain uh, about the uh, transfer second order control system that we plan to do, which is uh, so as per the calculation my friend told you just now. So we got the numerator 2 transfer function with the numerator 2, and then denominator is 1 2 3, which is s square plus 2s plus 3, which is this is the open one. Then we got again Then this is the feedback, and then step we got a basic initial input and final input one. So the thing, and then the out data and the time capture the details of the graph later for us to easier to analyze where what is the percentage overshoot. Everything will be more easier if we just use this. So right, so now run. So let's see the graph. So as you can see, this is the graph we update. So this graph is considered under them, and then the peak is somewhere here on 1.5 thing. Then the final value is for 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 correctly 0.4 seconds. And then time settling, everything here. It's already take a picture and then post it there in the report so we can see it more clearly. And one more thing I want to show you, this thing is the struct. So we're gonna write step info out data out time. So we will obtain all the information we need, which is throttling time, overshoot, peak time, and everything. So it's already there. So you just have to let's check whether the peak time is correct or not. So yes, I think so. It's correct. Zero point four so 8, 816, 818, 824, 30. The 30 is the highest, I think. So yeah, 30 is the highest. Okay, 1554. Is that correct? Somewhere there, it's just a bit more. Maybe our so you can see this. All the information is correct. So this is what I attached there, and then as per the calculation, so we already attached there. So later we will see on the difference between calculation and measure. I think that's all from us from the Simulink. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Okay, so right now hash kita kena convert transfer function to state space representation. Okay, kita ada beri transfer function 2 per s kuasa 2 tambah 2s tambah 5. So the state represent bila kita derive kita akan dapat dalam state space punya metrik iaitu is -5, -2, 01, B sama dengan 02, C sama dengan 10. Okay, bila kita dah simplifykan kita dapat dalam -2C tolak 5 tambah 2R. Okay, ini bila dah derive lah. Okay, kiranya state space representation ni, kiranya metric represent ni adalah dynamic untuk sistem dalam state space form, which is useful untuk various analysis dengan control design teknik. Seperti yang saya dah lukis iaitu macam itu untuk derive punya design punya teknik.
Hari ni saya nak explain pasal steady state error dan conclusion, discussion dan conclusion. Okay, first of all, steady state error. Ini for unit step input and for unit ramp input and for unit parabolic input. So tiga-tiga ni saya sudah siap dan inilah adalah say calculation here. Okay, so next discussion for the temperature control system of an air conditioning unit can indeed be effectively modeled as a second order system, and this approach is beneficial because second order system is provide a comprehensive framework to analyze and predict the dynamic behavior of many physical systems, include temperature control mechanism and modeling the temperature control system of an air conditioning. As a second order system offers substantial benefits in terms of design and performance optimization. The alignment between theoretical calculation and simulation results indicate that the model is robust and reliable. This understanding aids is creating more stable, efficient, and air conditioning system is ultimately leading NS comfort and efficiency. By leveraging these insights, engineer can continue to improve air conditioning technology to meet the demand of a modern living environment. Okay. Last but not least, we see about the conclusion. Okay, the conclusion, the comprehensive analysis of an air conditioning system is second order system provide valuable insight into its dynamic behavior and control features. The successful validation of a theoretical calculation with MATLAB simulation highlights the system's strong performance and stability. By understanding and optimizing key performance indicators, engineers can design air conditioning systems that maintain comfortable indoor temperature efficiently and reliable. This methodology can further expand to optimize system characteristics, enhance control strategies, and ultimately improve energy efficiency and user satisfaction. The dynamic behavior control feature air condition systems have been understood throughout their analysis as a second order system. This analytic approach, combined with MATLAB simulation and theoretical calculation, provides precision insight into a key performance indicators such as steady state error, percent overshoot, peak time, and settling time. Okay, that's all from me. Thank you.